Well, hello everybody. I'm Nick from the satellite team of the University of Louisiana. And today we're going to brief you on the hardware we're about ready to ship. It's composed of two PC boards. The first board we call the flight board, and there's actually two versions of it. The one on the right is actually our first prototype, and the one on the left is the beta version and the ones we will be shipping. So just quickly, let me briefly show you what's on this thing. So first of all is a LoRa radio. That's this division, this little chip here. Here are the sockets for the processor. And on this board, we're chosen itsy bitsy NRF 52840 Express module. This is a socket for a GPS, and we'll be shipping it with GPS on it. And here's a battery. So this device is the board that flies. And this is the device, well, this is the device it talks to. And this is the ground station. So here's the GPS antenna. There's a built-in GPS. Here's the radio, and this board has both a V and a UHF LoRa module in it. The UHF module is under this display. This display is not yet programmed. So now the big picture is shown in this block diagram here. So this block right here is the flight board, and this board is the ground station board. This flight board talks to the ground station board via a LoRa radio, and it's programmed to broadcast on 438 megahertz. This board talks to this board. This board now talks to the cloud via either cellular or hotspot. Once it's in the cloud, we dial up an Adafruit I/O server, and we will demonstrate that to you shortly. This is a receiver tuned to 438 megahertz. This display is a spectrograph that shows you frequency across the x-axis and amplitude across the y-axis. The balloon board is programmed to send its data about every 32 seconds, and you will see it transmit here in a second or two. Notice that the amplitude jumped up, and this is the bandwidth at which it's signaling on. And you will hear the traditional spread spectrum deal just now. So now, if you plug a terminal into the flight board, this thing will display the variable of the data that it's sending, and it's going to send about every 32 seconds. So basically, what it's sending here is its identifier, which is today W5UL, and this is a common delimited string that it's sending. Notice these variables are common delimited, and we parse that data, and we are sending 3 voltages and 3 currents and a temperature and the lat long and altitude of this board. And we repeat this data string every 32 seconds. In addition, this board will receive 2 commands sent from the ground station, or actually sent from the server. One is a ping signal, and the other is a cut down signal. So now let's talk about the ground station. So as a quick review, the flight board talks to the ground station, and the ground station is linked to a server. And the way you bring up the server is you go to a browser and you enter Adafruit.io, and I'm going to log out and log back in just to show you how to do that. So I'm logging out. Now I'm going to log back in. So when you log in, it's going to ask you for an email or a call sign. And the email that we're using on this demonstration is k5qxj@amsat.org. And the password is Joanne, exclamation, exclamation, 234. So we will sign in. This will bring you to the dashboard page. And today, the dashboard we're going to demonstrate is called Cape Ground Station. Click that, and that brings you to this screen. Now here come the variables. So the first thing we see up here is a map. This is reading the GPS that's located on our flight board, and this turns out to be where I'm located. Notice the green dot. Now the variables are displayed here as in the solar panel voltage. Well, since the balloon board doesn't have any solar panels, the voltage is 0, and of course corresponding current. In the satellite version, where we will be using the solar boards, this will be populated. Now we do have a battery in here, and notice that it's fully charged at 4.1 volts. All right, and if we had unplugged the USB port, we would actually be powering up from the battery, and it would display the battery current. This thing, if we send it a ground station signal, this graph will display the received signal level based on the transmissions from the ground. This is important because when this balloon flies away from us, we don't want it to get out of range. So any number above minus 115 dBm means the receiver should be decoding that. Now, there's a built-in thermistor on board, and it's reporting today at 74 degrees, which is the temperature in this room. In addition, we have a command panel over here. We have a panel over here, and we will issue the two commands. If you tap the 1, it would send a ping signal. If you tap the 2, it would cause the device to be cut down. And you can actually see the data by going to the feeds, clicking on the account over here and this top deal here. And as it updates, we should see the variables printed out here when they come through. And you notice there are timestamps here. And these are updated. So basically, we have described what we're trying to get you guys to fire up and give us some feedback. And if you have trouble implementing that, we encourage you to call me, and I will attempt to walk you through it. That's all for this day, for this transmission, and you'll be hearing from us via email soon.